Right. So this video we'll be discussing the May-June 2025 paper 1-5. Question number 1. We are given the equation of a curve and also the dy dx, the dy dx of the curve. It is given that the curve passed through the point. This is the passing point for the curve. Find the equation of a curve. So to find the equation of the curve, basically it is the y, right? So to get the y from the dy dx, okay, so to get the y from dy dx, that means from dy dx to the y, you have to apply integration. Right, yeah, so for this question, basically we have to apply integration. So to get the y, you have to integrate dy dx. So as the dy dx here, so I'm having 12, 2x minus 5 power 2 plus 8x. Okay, so 12 is constant. I just try to copy it. Focus on the integration of this bracket with power 2. So I copy the bracket power plus 1 divided by a new power. And after that, you have to differentiate the thing inside the bracket. Differentiate 2x minus 5, you get a 2, right? So you have to divide it by 2 as well. Then plus 8 is a constant, you just copy it. Focus on the integration for x power 1. When you want to integrate x power 1, you take the power plus 1, become a 2, and you divide it by a new power 2. Okay, then at last, don't forget about the constant term, which is a plus c. Okay, so before I found the c, I try to simplify my equation here first. I will be having this. And to get a c, I need a passing point on the curve. Okay, so the passing point given here is 2, 4. Substitute the 2, which is the x coordinate, and also the 4, which is a y coordinate or y value, into the equation. I will be having 4 equals to 2. Then 2 times 2 minus 5 power 3. Then 2 square plus c. And from here, you will be getting this. Do we get here is we'll have c equals to negative 10. Okay, then usually for me, I prefer to rewrite my answer again in a complete way. So I'm having y equals to 2, then 2x minus 5 power 3 plus 4x squared minus 10. Right, so this is what we have for the equation of the curve. Question number 2. In the expansion of this bracket plus this bracket, the coefficient of x squared is 6 times the coefficient of x. So find the possible values of the constant a. Alright, we are having a binomial expansion. What is the general formula for a binomial expansion? Okay, so if let's say I'm having x plus y power n, the general formula will be NCR, x power n minus r, y power r. Okay, so this is general formula for all the terms are in our binomial expansion. It is provided in the formula booklet. Just in case you can't remember, you can still search from the formula booklet. Right? Okay, and now let's have a look for our question here. We are actually having two parts of the bracket. Yeah, I'm having first bracket power 5, then another bracket power 4. Therefore, I need to expand the x squared term and also the x term for this both bracket here. Okay, so maybe I try to use it. I use a different color to represent the power, the bracket, okay? For the first bracket, I'm using the red color, 3 plus ax power 5. For the second bracket, maybe I'm using the green color, where it is actually 6 minus 4, 6 minus x power 4. Okay, so for the first bracket, I try to expand this particular bracket, and I'm interested in the term of x squared and also x, right? If we have a look for our expansion here, our term at the back is ax. So basically the x squared and also the x will come in from the second term here, the ax here, right? So how can I make the ax here with a power 2 and also the power 1? So I think it's quite obvious. For this red color bracket, you should be having 5c something first, yeah? 5cr, maybe I put it at 5cr. Then 3 power 5 minus r, ax power r. And you know that according to the question, we are interested to have the coefficient of x, the x power 1. How can I get x power 1? For this general formula here, you need to make sure that your r is a 1. If you make sure that your r is a 1, you'll be having a power 1 and x power 1 later, right? So 5 minus 1, you'll get a 4. Okay, then also this one will be the 1. So you can see that most of the time I try to use the try error method, the try error method to get the answer, the value for the r, right? Okay, so you're having 5c1, 3 power 4 ax plus 1. This is the x term at the first bracket here, first expansion here. After that, we are interested for also for the coefficient of x squared, right? So to get the coefficient of x squared, again, the same thing happen. You'll be having 5cr, 3 power n minus r, which is a 5 power, it should be 5, n is 5 here, 5 minus r, and then ax power something, ax power r. How can I get the x square here? So to get the square, I need to make sure that my r is a 2, because I'm having x square after I put the square, the 2 here. So 5 minus 2, you get a 3, and the r, the value of r is actually a 2 here, right? Okay, so we are having the x term and also the x square term for the first bracket. At the same time, I also need to have the x term and x square term for the second bracket. The general formula for second bracket is 4cr, 6 power 4 minus r, and also negative x power r. Again, we are interested for the coefficient of x power 1. So how can I make this particular term as power 1, x power 1? You have to make sure that your r is a 1, right? Then 4 minus 1, what do you get? You get a 3. And also 4cr, just now we already know that the r is a 1 here. Okay, so the same thing happened. Basically, you just need to try to repeat the process. So now we are looking for the x squared. How can I get the x squared term? In this second bracket here, it should be 4c2, then 6 power 2, negative x power 2. So just like what I showed you just now, you try to draw an error a bit to get the term for the x squared. Okay, so after I successfully get all the term for x power 1 and x power 2 for both brackets, then let us try to simplify it now. Okay, so for 5c1, 3 power 4, ax power 1, right? If you simplify, you should be having 405 ax. Okay, then for the second term here, 5c2, 3 power 3, a square x squared. After you expand it, by right, you'll be having 270 a squared and also x squared. Next one, for the green color one, for the x power 1, by right, you'll be having negative 864x. You try to expand all the details here by yourself and try and see whether you're able to get this or not. Then for the last term here, after you expand everything, by right, you'll be having 216x squared. Okay, and now, because from the question, we know that we want to compare the coefficient of x squared and also the coefficient of x. So what are we going to do now is we try to combine the x together, compile all the x squared together. So I try to compile the x first. I'm having 405a and also minus 864x. Then for the x squared, I'll be having 270a squared, then plus 216x squared. And you can see that I try to factorize out the x squared. Okay, so the coefficient of x is this one. Coefficient of x squared will be this one. Right, then continue and have a look what is given by the question. Coefficient of x squared, 6 times coefficient of the x. So we try to write out one equation by using this information here. Coefficient of x squared is this one, right? So you write 270a squared plus 216 equals to 6 times. So equals to 6 times. The coefficient of x is this one. So I'm having 405a minus 864. By using the information given here, you get this equation, and you can continue to solve this equation to get the value of a. Alright, so I try to simplify. The next step by right, I should have this one plus 36 I divide the 6 on the left hand side so that the 6 here, I move it to the left. Then I'm having 405A minus 864. Continue further to simplify them. So basically, I try to group everything on the left and I get the quadratic form equation, right? The quadratic equation. I think I can still further simplify it. And from here, to solve the quadratic equation, we are using the technique that we learned earlier where we can try to factorize them. And after that, from here, you'll be getting the value of the A. So there are two values for A. A can be equals to 5 or A can be equals to 4. Right, so this is how we solve question number 3. Use completing the square to find the exact solution for this equation. Highlight the keyword exact. That means your answer later cannot be in decimal number. It must be in surd form or pi form or e form. Okay. Alright, so the exact solution is the important formula. Is the important word. Okay, for this question, they want you to use the completing square. That means when you want to solve it, right, you have to make sure that you try to complete the square for the equation first. To complete the square, I have to make sure that the coefficient of x squared is a 1. Therefore, I take out the 4 first. Then I'm having x squared minus x. After that, I have to plus something square and minus something square. So what's the plus and minus something square here? Then the negative 1, I just take out. I just put it at the last term lah. Okay, equals to 0. So the something here inside your completing square part should be the coefficient of x divided by 2. So you are seeing that this is negative 1 divided by 2, you'll be having negative half. Okay, then after that, the first 3 terms in your step here to complete the square, you want to combine them, become a big bracket with the first and last term and a square outside. Okay, then for this part, this one, half negative square. So you'll be having 1 over 4 positive, then minus 1 equals to 0. So basically from here, you can see that we're trying to, we already successfully complete the square, right? Then to continue further, I want to multiply the 4 into the bracket, and I will have having this minus 1, then minus 1 again equals to 0. And now if I move the number to right hand side, negative 1 become negative 2, right? Bring over become positive 2 divided by the 4. And for this step, basically you will be having 1 over 2. Okay, I want to take the square root both sides, then have to consider the plus and minus sign for 1 over 2. Okay, so of course you want to change it become 2 over 2 also can. When you want to rationalize it, they are the same answer actually. And next one, I will want to bring the half over. That will be having half plus minus 2 over 2. This also tells us that basically we're having 2 answers. The first one is, if you want to write in single fraction, so it should be 1 plus 2 over 2. Another answer will be 1 minus 2 over 2. Okay, so should I change the answer into decimal number or not? Shouldn't. We don't do that, yeah, okay? We will keep our answer like this because this is actually the exact solution for the x. So the word exact means that you have to keep it in the surd form or maybe the pi form according to what you have like in the question. Alright, so this is what we have for part A. Then let's continue to part number B. Hence, solve this equation here for data between 0 to 180. Let's have a look for the equation here. I'm having 4 tangent theta plus 1 over tangent theta. Sorry, I think I copied wrongly. So 4 tangent theta equals to 4 plus 1 over tangent theta. Okay, so how should we continue from here? To solve the equation, what I want to do is that I try to get rid of the denominator for this one. Okay, so I multiply the whole equation by tangent theta. And then I move all the number to one side and group them on the left equals to 0. If you try to observe this equation, basically it is very similar to what we have in part 1. Usually, when you're having part A and part B, like what I told you earlier, usually for part B, right, you need to try and link with some solution or maybe some value or some equation that you prove in part A. So if you have a look for part A here, you're having 4x squared minus 4x minus 1. If you try to have a look here, you're having 4 tangent squared minus 4 tangent minus 1, which is the same pattern here. How can you continue to solve it? Just now we have learned how to get the value for the x, right? But now your x become the tangent theta. And I will directly use the result just now. X is equals to half or 1 plus 2 over 2. Then I will change the x become the tangent theta. Same thing happens for the negative part. So I'm having tangent theta equals to 1 minus 2 over 2. Okay, then let's continue further and solve it. They are interested from 0 to 180 for our answer. That means when you want to draw the quadrant, we only focus on the first and also the second quadrant. 0 to 180, right? Okay, so for the first quadrant, if you want to get an answer, the answer should be the theta, where I define this as a basic angle. Then for the sign, in the second quadrant, sign will be positive. So to get an answer from this quadrant, you have to take 180 minus the theta, which is the basic angle also. The theta is basic angle. Okay, so let's have a look for this first equation here. Tangent theta equals to 1 plus 2 over 2. To get the basic angle, you try to press tangent inverse, then this value on the right. When you press the calculator, by right, you'll be having 50.4. Okay, then once you get the basic angle, then we need to go through the quadrant to get an answer for the theta. We are looking for tangent positive. In the first quadrant, is tangent positive? Yes. So I want to get an answer from here. So what's the answer for this part? It is actually the theta, which is the basic angle, yeah? So we'll get the basic angle as answer. In second quadrant, is it tangent positive or not? No. So I don't want to get the answer from this quadrant, so I will just stop here. Alright, because the theta is within the range of 0 to 180. Okay. Then let's have a look for the second equation here. Try to figure out the basic angle first. If you try to press the calculator, this value is a negative value. Please ignore the negative value and just press tangent inverse positive answer for this one. By right, you'll get your basic angle equals to 11.7. Okay, after you get the basic angle again, try to figure out the theta. Tangent, this value, if you press calculator, it is a negative value. So that means I want to accept the answer with the quadrant of tangent negative. In the first quadrant, is tangent negative or not? No, right? So I don't want the answer from this part. So continue further. In the second quadrant, is tangent negative? Yes. And I want to get the answer from this part. How to get the answer from this part? You have to take 180 minus the basic angle. So that means you are taking 180 minus 11.7. Then you'll be having 168.3. Okay, then my personal habit will be I usually prefer to rewrite my answer again at the last step to group all of them together. And this is what we have for the question number 3. Question number 4, we are given a diagram, and after that, the equation of the curve is this one. Shaded region is bounded by the curve, the line x equals to 2, and also the x-axis. Find the volume form. Okay, highlight the keyword volume. When the shaded region is rotated through 360 degrees about the x-axis, giving your answer correct to 2 decimal places. Okay, then now, to get the volume, right, the formula for volume will be, let us have a look for the question again. It is rotated through x-axis. Therefore, to get the volume, you have to apply integration, and you have to, with respect to the x, so you have to integrate something with the x because of the word rotate through the x-axis. And what is the formula inside? The general formula to get the volume will be pi y squared dx. Okay, And after that, we need to have the limit a and b. The limit a means the value of x where the area starts. The value b means the area where the value of the x where the area ends. Okay. Alright, so for this question, we are having the y. Okay, maybe you try to set the question first. Alright, so let's have a look for the volume. Okay, so to get the volume for this equation, for this diagram, I need to have the integration of something dx. Then it should be the pi, and then y squared. So what do I have for the y? This is my y. Then if I want to square it, I will be having negative 1 over x squared. Then with a square outside, pi y squared. Okay, so you can see from here pi y squared, which is very obvious. And now let's have a look for the limit here, where the area starts. So the area or the volume starts at this point. I don't know what is the value for this. I need to figure it out now. Where the area ends at the line x equals to 2. So the upper limit will be the 2. And we still need to find the lower limit first, yeah? Okay. How can we find the lower limit? Very easy. It is actually the x-intercept for this equation, right? What can we do? At the x-intercept, you should know that y equals to 0. When y is equal to 0, you're having x squared minus 1 over x squared equals to 0. You'll be having x power 4 equals to 1 after you simplify it, and then you will have x equals to plus minus 1. And very obvious from the diagram, right? The value of x that we have here should be a positive 1. So I put a 1 here. Okay? After we successfully solve the question or the equation, then we can start the integration. Pi is a constant. Usually for me, I prefer to take it out from the integration part. For this bracket x squared minus 1 over 2x squared, you cannot directly integrate it like that. You have to expand it first. So you're having x power 4 minus 2ab means negative 2 plus 1 over, plus b squared. So you're having 1 over x power 4. Okay, after you expand it, only you start the integration. X power 4, power plus 1 become a 5 divided by a new power. Negative 2, when you integrate, it will become negative 2x. X power negative 4, power plus 1 become negative 3 divided by a new power negative 3. Put in a limit 1 and 2. Again, my personal habit is I prefer to simplify my expression first before I substitute in any value. So for me, I'm having this. Okay, what is the next step? So the next step is we are trying to substitute in the 2. I will be having 2 power 5 over 5 minus 2 times 2 minus 1 over 3 2 cube. Okay, this is what I get when I substitute the 2. Then after that, I have to substitute the 1, right? So the same thing happens. 1 over 5, 1 power 5, minus 2 times 1, minus 1 over 3, then 1 power 3. Okay, so I try to substitute in the limit 2 and 1 into the expression that I get after the integration. Then you can directly try to simplify them. So by right, if you didn't do any careless mistake, right, your final answer for this part should be 14.11, correct to 2 decimal place. Okay, so I try to fulfill what the question wants, and I'm writing it into the 2 decimal places answer, which is 14.11. Right, so this is how we solve question number 4. We are now at question number 5. The diagram shows a sector ABD. We are having a sector ABD of a circle with the center A and also the radius 10. Radius 10, so you can see that this is basically the radius as well. This length is a 10, and you can see AB is also a 10, right? Okay, and now this is the radius. Now they say that the perpendicular bisector of AB pass through the D. They are explaining this line here, okay, the perpendicular bisector for AB. Therefore, you can see that AC is a 5, AD is a 5, CB is a 5. Then first part, they want us to find the perimeter of the shaded region. Perimeter. giving your answer correct to 1 decimal places. I know this length, right, which is a 5 parameter CB. I need to figure out a method to find out the length of CD and also the arc length for DB. Then only I can get the answer, right? Okay, so CB no problem. This one, the general formula will be R theta. R theta means that R is a tan, which is the radius of the circle. Theta is the angle here. This is the theta. And we actually don't know what's the value for theta here. We also don't know what's the value for DC here. Okay, so we are having a few information to figure out first before we can get an answer. Alright, so now I want you to have a look for this particular triangle here. It is a right angle triangle, therefore it will be very useful for us, okay, to figure out some value that we need. Okay, let's have a look for this blue color triangle, yeah. I know that the length AC is a 5, AD is a 10, right? That means if I try to write out the equation, cos theta will be equals to 5 over 10, where 5 over 10 means half. What's the value for cos inverse half? You'll be getting actually 60 degrees, which is pi over 3. So I keep my theta in the pi over 3, right? And after that, I want to get the length for DC. How to get the length for DC? We know that we can use the Pythagoras theorem to find the DC. Hypotenuse length square minus the adjacent length square. You'll be having square root of 75. Okay, and now we have the theta. We have the length of DC. To find the perimeter, it shouldn't be too hard. Okay, so how to get a perimeter? So like what I told you just now, perimeter means that we are adding all the sides of the shaded area. Okay, so one side is C to B, it is a 5. Then after that, we are having D to C, which is the value that we get just now, square root 75. And we just put it as square root 75 first. Then what is the length for the arc here? It will be R theta. R is a 10, and theta we know that it is pi over 3. So we write as 10 theta, R theta here. Okay, then again, just use a calculator to help a little bit. By right, you will be having this as parameter 24.1. And why I keep it into this way, because of they are asking for 1 decimal place. So this is actually 1 decimal place answer. Okay, yeah, and this is what we have for part A. Let's continue to part B. For part B, what they want us to find? They want us to find the area of the shaded region. Answer into 1 decimal place as well. Let's have a look at our question again here. The diagram, if you refer to the diagram, maybe it is easier for us to solve it. Okay, right. So before that, maybe I try to shift my answer a little bit. Okay, I shift it back to the space here. Okay, then this one also the same thing. I try to shift it. Okay, and now, just now we already successfully get the value for theta and also this length. Okay, so the theta is actually pi over 3. And this length is actually square root 75. And now we are looking for the area of the shaded region. To get the area of the shaded region, I think it is not too tough also. Basically, you can take the area of the sector. This is a whole sector, right? After that, I want to minus the triangle. So you take sector minus triangle, then you can get the shaded area. I try to write out the formula first. The shaded area is sector minus the triangle. Okay, so what's the formula for sector? The area of a sector. So the area of a sector basically is half r square theta. Let's put in our value here, half r square. What is r? R is a 10 square. What is the theta? So theta just now you get is pi over 3. minus the area of the triangle. How to get the area for triangle here? It is a right angle triangle, right? What can you do is that you can take half times base. Base is a 5. What is the height? The height is square root of 75. Okay, when you're trying to write the solution, just try to keep your answer in the formula form. So from here, you know that it is actually half r squared theta. From here, you know that it is actually half times base times height. Okay, then again, try to use calculator a little bit to simplify the answer for you. If you didn't do any careless mistake, your answer should be quite long. And this question is asking for 1 decimal place, right? So I'm having 30.7 as the final answer. Okay, this is how we find the area for the shaded region. Right, so now we are at question number 6. Each year, on her birthday, Ananya received some money from each of her parents. So for the first birthday, right, fathers give her $10. Every subsequent year, her father gave her $5 more than he gave her the previous year. So let's have a look for the father's amount given, yeah? Amount given by the father. First year is 10. It will be $5 more for than the previous year, right? So if let's say the first year is a 10, then how about the second year? The second year will be 15, right? How about the third year? The third year will be 20. Okay, then so on. The next year will be 25, and of course, we'll continue here. Okay, we don't need to list out everything. And let's have a look for the mother one. So for mother, also gave her $10 at the first year. So mother, first year is $10. Every subsequent year, her mother gave her 20% more than she gave her the previous year. So for the next year, yeah, okay, you'll be having $10. Okay, for the next year one, the amount will be $10 plus 20%. So the $10 here is 100% plus the 20%. Total, you're having the 120% of the $10. So when you try to write it out in percentage or maybe in the ratio form, 120% is basically 1.2. So it is actually 1.2 times of the $10. So what you can do is that you can put it like this. $10, then 1.2 times. Then for the next year again, it will be another 1.2 times of the previous year. So you're having 10. This is the previous year amount, and then you need to multiply 1.2 times for the next year. And when you try to simplify 1.2 and 1.2, you can see that it is basically a 1.2 squared. How about the next year? It will be 10 multiplied with 1.2 power 3 and so on. Okay, so I don't know whether you're aware or not. If you try to have a look for the amount of money given by father and mother, right? For father, it actually form a it actually form a progression, and you can see that the amount increase is fixed or constant every single year. And this progression, we call them as arithmetic progression, right? And therefore, for father's one, it's actually an arithmetic progression. How about for mother? So for mother, if you have a look there, basically it is the multiplication of ratio. This one is plus 5, plus 5, plus 5. Then for the mother's one, you have see that it is actually multiplied with 1.2. Then for the second and the third year, also multiply with 1.2, and so on. Okay, and this progression basically is a geometric progression. All right, and let's continue further. Yeah, for part A, they want to show that on her 11th birthday, she received more from her mother than from her father. Okay, if I want to know the 11th term, so the first birthday means first term, so the 11th birthday means 11th term. For an arithmetic progression, what's the general formula for the 11th term? So Tn is a plus n minus 1d. Just a small recall here. And then for the geometric progression, it will be ar power n minus 1. Okay, all right. So let's calculate the amount of father given on the 11th birthday. So T11, your n is equal to 11 here. It will be A. A is a 10, first term, plus n minus 1d. So n is 11 minus 1. D is the common difference. So you can see that the amount added is $5 per year, right? So the D is actually equals to 5. And from here, you'll get 60. How about the amount given by the mother? So for mother, it is a geometric progression. So to apply the formula, A is also a 10. R is the common ratio, where it is the value, okay, that we multiply every single year. So it should be 1.2 power n minus 1. So n is 11 minus 1 is a 10. So by trying to use the calculator, you will get a value 61.9. So I think very obvious that she received more from her mother than the father, right? So you can write 69.1 is more than 60. Therefore, money given by mother is more than father. Okay, then let's have a look for part B. For part B, they are asking the total amount of money Ananya received up to and including her 18th birthday. Up to and including her 18th birthday, that means you are having the sum of the 18th term. Okay, so now, again, for arithmetic progression, to find out the sum of the first n term, basically the formula will be n over 2, then 2a plus n minus 1d. For the geometric progression, to get the sum of the first n term, the general formula will be a r power n minus 1 divided by r minus 1. Or if you want to use 1 minus r power n divided by 1 minus r also can. Alright? Yeah. And now they are asking for the total amount. So I have to calculate the total separately from father and mother because they are belonging to two different progression, right? Okay, so for father part, if I want to have the sum of the first 18th birthday, the general formula will be n over 2. So 18 over 2. 2a, so 2 times 10 plus n minus 1d. So n is 18 minus 1. D is a 5. Okay, when you total them up, the amount that you get should be $945. And the sum of money from mother will be A. A is also a 10. R is 1.2 power n. N is 18. Then minus 1 divided by R minus 1. So I'm having 1.2 minus 1. Then for this question here, you'll get the amount 1281.17. When we are talking about maybe the money, right, we are having two decimal places until the cents, right? Okay. Then what's the total amount that they get? So the total amount will be 945 plus 1281.17. Then the total amount that I get is $2226.17. So this is my answer. I will keep my answer into two decimal places because of it is in the context of the money. Alright. But of course, if you want to correct to three significant figure also can. But for me, I will just keep it into two decimal places. Alright. So this is how we solve question number. We are now at question number 7. Okay. In the parallelogram ABCD, the coordinate of A is given. B is like this with a P. D is this one, and also it is given that the gradient of AB is negative 2 over 3. Find the value of the P. Okay, when we are having a parallelogram, right, we should label all the vertices in either clockwise direction or anti-clockwise direction. So I'm having A, B, C, D. So what am I going to do is like maybe I simply label them. I'm having A here. Then maybe this is my B. Okay, so the A is having 3, 7. B is having 6, P. Then for the C, maybe I label it in this way. So let's say this is a C. I don't know what is the value. And D is 1P. But if you try to observe a little bit about the Y coordinate of the B and also the D, right? Basically, you realize that B and D are having the same coordinate of the y. So maybe I have to change my diagram a little bit. Okay, so I have to put maybe like this. Then this is my b. Okay, this is my b, which is 6 and p. Then after that, if let's say this is the c, can it be c like that? Then this is the d. Oh, sorry, maybe this is a c. Then this one should be the d. Okay, where the d is at the same y coordinate with b. Maybe we can make it like this. Can it be like that? Or maybe we try to make it nicer. Okay, wait. So I'm having A to B. Then my D must be somewhere here. Okay, then if let's say I want to have B and C. B and C. This is the B and C. So my D should be somewhere here. Yeah. This is my D. Okay. Then where A and B, AB and also DC is parallel, then D, A and also CB is parallel. Okay. Then I'm having 6P here. Then this is the coordinate of 1P. Okay, then C, I don't know what's the value. But of course, this is not the correct diagram. If you want it to be more accurate, of course, you can plot it. But in my suggestion, we no need to spend too much time on plotting the graph. Okay, so some students say that, oh, this graph is not logic because our D, the x coordinate should be in front of A. Then if you want, you can roughly change it, if you want. Then we can just change it, become something like this. Maybe I'm having the D here. Okay, therefore the C should be somewhere here. So maybe it is something like this. Then more logic, right? So this is actually 1p, 6p, then C, I don't know what is the value. And now we actually know that the gradient of AB is equals to negative 2 over 3. Okay, what's the formula for gradient? The formula for gradient will be y1 minus y2 divided by x1 minus x2. And since they give us the value of the gradient of AB, therefore I can use this formula to calculate the value of the P. So to get the gradient of AB, let's have a look for A and B. What should we do here? You can take 7 minus P divided by 3 minus 6. And this value is the gradient of AB, which is equals to negative 2 over 3 given by the question. Okay, then you're having 2 equals to 7 minus P. And from here, you can get the value of P, which is equals to 5. This is what I have for 7 part A. Then let's continue to 7 part B. Find the coordinates of C. Alright, so to find the coordinate of C, there are many ways for you to apply it. Okay, there are many different techniques. So some students, they are looking at the difference of the coordinate from A to B and also from D to C because they are parallel, right? Or some students, they might use the difference of coordinate between AD and also BC, also kind of up to you. Alright? Yeah, so maybe I will take AD and BC. Okay, so from A to go to D, right? The triangle that we have here is this one, where we are going to move down. 7 to 5 is move down 2 units. Then for the horizontal one is you are moving it to the left hand side 2 units, right? So minus 2. From A to D, you move down 2 units for the y coordinate. You move to the left 2 units for the x coordinate. Same thing happened here for the D, for B to C. So going down should be negative 2 units. Then going to the horizontal also negative 2 units. So to get the C coordinate, what we are doing is we take the B minus 2 and also we take the y coordinate for B minus 2 as well. And eventually what do you get here for the C? It will be actually 4 and also 3. Okay, so this is a more, to me, I think it is a more straightforward method for part number 2, for part number B. Okay, or maybe some students, they said, oh, I want to form the equation and find the intersection point for the line. Also can, but it will be very long and tedious. And this question only gives us 2 marks, right? So you can use this concept, right, to just figure out the coordinate for C here. Alright, then let's continue to part C. Now they said find the area of triangle formed by the perpendicular bisector of AB and also the x and y axis. Okay, perpendicular bisector of AB is a line. Then cover the triangle is also formed by the x and also the y axis. If you try to observe from the diagram that we draw here, so some students say, oh, it will be very useful if I try to draw a diagram nicely just now, right? Yeah, it is possible, but you can try to also try to guess how the triangle look like, okay? We are having the line AB here. Midpoint will be this one. Perpendicular line will be something like this. That means you need to draw a line 90, pass through the midpoint of AB with 90 degree. So maybe this is what we have. Okay, so this is a line, perpendicular bisector. So the black color line is the perpendicular bisector. And then do you see where's the triangle that we have? Covered by the line, x and also the y axis will be this one. Okay, so first of all, what we need to do is that we need to find out the equation of the perpendicular bisector. After that, we can try to figure out the x coordinate. We try to figure out the y coordinate, x intercept and y intercept lah. Okay, for the perpendicular line, the perpendicular bisector. Then the x coordinate will be the base, the y coordinate will be the height of the triangle. So this is the flow that we are going to do lah, right? Okay, so let's continue further. So first of all, let's get the equation of the perpendicular bisector. Before that, we need to find the midpoint first, because midpoint is the passing point of the perpendicular bisector. So first of all, the coordinate for A is 3, B is the 6 divided by 2. Then the coordinate, y coordinate for A is 7 plus B is a 5, then divided by 2. And we'll get the midpoint, which is actually 9 over 2 and also 6. So that's the midpoint. And then now we want to find the gradient. The gradient of the perpendicular bisector multiplied with the gradient of AB should be equals to -1 because they are 90 degrees to each other. And since we already know the gradient of the AB just now in part 1, right? It is actually -2 over 3. Therefore, we can get the gradient of the perpendicular bisector, which is equals to 3 over 2. Then let's continue further. We can figure out the equation of the perpendicular bisector. Equation of perpendicular bisector. Okay, so what do we have here? It will use y minus y1. So y minus the y coordinate equals to m gradient x minus x1. So x minus 9 over 2. Okay, then from here, if you try to simplify further, by right, we should get this -3 over 4. Okay, so next we want to get the x and y intercept, right? So we will let y equals to 0. What do we get for the value of the x? So 3 over 2 minus x minus 3 over 4 is equals to 0. So from here, you'll get the value of x, which is equals to half. Then you let x equals to 0 as well, so that you can get the y coordinate. So you're having y equals to 0 minus 3 over 4. So from here, y is equals to 3 over 4. So what does it mean here? That means, according to the diagram that we draw, the value of x, for this part, the x-intercept is a half. Then for the value of the y here is -3 over 4. Okay, so to get the area of the triangle, you have to take half times base, which is the half, times height, which is 3 over 4. Okay, so area of triangle, we can figure it out. Area of triangle is half times base is the half times height, it is the 3 over 4. Oh, sorry, I forget to put a negative here. Okay, Then simplify it. The area that you get should be 3 over 60. So this is how we solve question number 7. Alright, so we are now at question number 8. We are given the equation with this curve, this equation, yeah, a curve with this equation. Then we are having a stationary point at this, okay, x equals to 1, y equals to 9. Find the values of the constant a and b. Alright, so we need to know the keyword stationary point. We are having stationary point when the dy dx is equals to 0. It will be useful for us later when you want to solve for the question, solve for the answer, yeah. And then the 1 and 9 is the passing point. So passing point, that means if you substitute 1 and 9 into the equation, you will get the equation correctly, right? Okay. For this question, they want us to find the value for a and b. So let us start. We are having two constants here, right? The a and b. To get the value for a and b, very likely you need to have two equations. Okay, and then after that, you have to solve them simultaneously. Right, so let us form the first equation here. We are having the passing point 1, 9 on the curve. Therefore, I will substitute y equals to 9 and also x equals to 1 into the equation that we have. Okay, then after that, what do we have is you should be having a plus b equals to 3. If you try to simplify the whole equation, right, then I will make it as a equals to 3 minus b. And this will be my first equation here. Right, so I have used the passing point given in the question. And then how can we get the second equation here? To get the second equation, what we can do is like, we can use the information of stationary point. At stationary point, we're having dy dx equals to 0. So let's find out the differentiation first. So dy over dx, what do we have? Differentiate x power 3, you'll be having 3x squared. Differentiate ax squared, you'll be having 2ax. Differentiate bx, you'll be having a b. Okay? And then when dy dx is equals to 0, the x coordinate that we get is actually a 1. So you substitute 1 into the x. And but from here, I believe that you will be able to get the second equation. So your second equation will be 0 equals to 3 plus 2a plus b. And I will put this as the second equation. To get the value for the a and also the b, we just try to substitute 1 into 2. Or you can try to solve the equation simultaneously, right, no matter how. So you'll be having 0 equals to 3 plus 2, then the a is 3 minus b, then plus b. Okay, simplify the equation. From here, I think very easily, you'll get the value of the b, which is equals to 9. Let's continue to find the a. You can substitute the b into either one of the equation. So 3 minus 9, I substitute into 1, right? Then from here, I'm having a equals to negative 6. And this is how we solve the part A. Then let's continue to part B. For part B, they want us to find the coordinate of the other stationary point. So again, to find the stationary point, you need to let dy dx equals to 0. Okay, let us write out the equation of dy dx that we get in part A just now. So from part A, I get 3x squared. Substitute the a inside, you'll be having negative 12x. Substitute the b, you'll be having the 9. Okay, because previously, what do we get here is dy dx is equals to, let me have a look here. So originally, we are having this 3x squared plus 2ax, then plus b, right? And because of we already get a equals to negative 6 and also b equals to 9, substitute it into the equation here, and this is what you get. Okay, then how to find the other stationary point? So the concept is still the same, where dy dx equals to 0. Please let dy dx equals to 0. And then to solve the equation, I realized that I can simplify them first before I solve it. this one should be a 3, right? Then this is a quadratic equation. From here, I can try to factorize it. So I will be having x minus 3, x minus 1. So from here, I'm having x equals to 3, then x equals to 1. So this is actually the point of what the question gives us just now, right? This is a point of 1, 9. So we don't need to continue and calculate this one anymore. We are interested for the other point. So the other point will be having x equals to 3 for the x coordinate. To get the y value, what should you have? So substitute into your y equation just now. So 3 cubed negative 6 times 3 squared, that means ax squared, then bx plus 5. And from here, you'll get your value of y, which is equals to 5. Then that means this is the coordinate for the other stationary point. Right, then let's continue to part C. For part C, now they are saying that we have a point P moving along part of the curve in such a way that the y coordinate of P, y coordinate is increasing at a constant rate of 6 units per second. When you are seeing the keyword rate, that means it is about the rate of change. All the symbol for rate of change will be something over dt. We are talking about the y coordinate here, so it should be dy over dt. And it is equals to 6 units per second. It is equals to 6. This 6 should be a positive value because of the word increasing. Okay, if they are mentioned in the question that we are having a decreasing rate, that means you have to put a negative value to your rate, right? So this is a positive. Okay, find the rate at which the x coordinate of the p is increasing when x equals to 5. And now they are interested to figure out what is the value for dx dt. Okay, so to find out the rate of change for the x coordinate, you need to apply the chain rule where I'm having dx over something multiplied with something over dt. And from the equation here, right, from all the question here, we already get the dy dt. So that means the something here should be the dy. Alright, okay, then let's have a look for the previous part now. Let us recall again what is my dy dx here. So my dy dx basically is equals to 3x squared minus 12x plus 9. When x is equals to 5, what is the value for my dy dx? So please substitute inside. So we're having 3 times 5 squared minus 12 times 5 plus 9. Okay, so if I didn't do any careless mistake, right, by right, this value should be 24. Okay, and now let's put it back into our chain rule here. This is dy dx, and I want to get dx dy. Therefore, it will become 1 over 24. What's the value for dy dt? It is given in the question, which is a 6. Simplify these two values here. By right, you'll be having 1 over 4 units per second. Okay, and this is basically how we find the dx dt. Okay, question number 9. Describe fully the transformations that have been combined to transform the graph of fx to gx. We are having the function fx, we are having the function gx. Okay, so you can see that both of them are having the basic function, which is the cos x, okay? And they want us to describe the transformation that has been combined from f to g. So let's have a look here. Fx is the basic function cos x, and gx, you can see that you're having a 3 here. It is a stretch in the y because you multiply the 3 outside the cos, right? So it should be stretched in y. So this one we can put a note here. This is stretched in y. You're having a minus pi inside the basic function cos. This is basically the translation in x. You're having a plus 2. outside the function, outside the basic function. So the plus 2 here is also a translation in the y. Okay, so in short now, when you are having fx, right, basically you will realize that you multiply the 3 outside the basic function, but you have a minus pi inside the basic function, then you're having a plus 2 outside the basic function. So your gx looks something like this. Okay, and how can you describe it using statement, the sentence, right? Okay, so for me, right, I will tell the students always, when you're having two transformation in terms of y, right, this is stretch in y, this is translation in y. For the direction of y1, we follow the normal mathematical operation. That means you can see from here, you multiply the 3 first, only you add the 2 at the back, right? Therefore, the very first transformation should be stretch. So stretch. Okay, so stretch you have to mention in what direction. So in y direction. Then what is the factor that you stretch it? So you have to make sure that you write out the stretch factor. So with a stretch factor of 3, because you multiply with 3, right? After that, I'm having the translation in x and also the y. I can combine them into one step where we are having translation with the vector. It will be pi and also 2. Okay, so this is the transformation involved in the question for part A, 9A. Alright, then let's continue further. On the given axis, sketch the function fx and also function gx. Okay, so let's start with function fx first. Yeah, so you're having cos x, and then they want us to consider from 0 until pi. Okay, so how can we sketch it? We try to think about the normal graph for cos, the basic graph for cos. So the original cos graph looks something like this. I know that this is the pi, this is a 0 and 1 with -1. Okay, therefore we can try to draw it out here. Okay, where maybe I label this as a 1, then this one is a -1. It will pass through the x-axis at pi over 2. So maybe in between I label a pi over 2 here. This is a pi over 2. Okay, then we want to plot the diagram. It will look something like this. You're having a maximum point, then x-axis, then minimum point at x equals to pi and also y equals to -1. So you try to join them together. This is basically how your cos graph look like. So don't forget to label them where this is fx equals to cos x. Okay, and now they want us to sketch the diagram of gx also. To sketch the gx, I also start from function fx that I have. So like what I know just now, right? So we have already explained what kind of transformation do we have. So the first transformation is multiply the 3. When you multiply the 3 outside the function fx, you will basically change the value of the y. So that means you are still having the cos x graph here. Okay, then the value 1 times 3 become a 3. The value -1 times 3 become -3. Okay, but it is still from 0 until 2 pi like this. After that, I need to have a translation of x is pi unit to the right, y is 2 unit going up. So when you want to sketch pi unit to the right, that means this part, the 0, you move it to the pi. Okay, then this original pi, you move it pi unit to the right, then it will become something like this. So your graph will become something like this, the purple color one, after you move it pi unit to the right. Then after that, you have to move up 2 units because of plus 2. So when you want to move up 2 units plus 2, the 3 here, you need to add 2 units, become a 5. So you shift up, it become a 5. Okay, then for the -3, you also shift up, become -1. So the minimum point now become -1. And after that, the x-intercept. The x-intercept originally is the x-axis, right? You move out 2, you need to become the line y equals to 2. Okay? So we roughly know that my final graph will look something like this. Okay, I'm having pi, then to 2 pi. The highest point is a 5 at the pi. Then you pass through the 2 at 3 pi over 2. Then at 2 pi here, it is -1. So basically, it will look something like this. Okay, and let's try to plot it out. I think my ratio is not nice enough, yeah. So I'm having 1, then maybe 2, 3, 4, 5. Let's say I'm having a 5 here. Okay, then 2 is maybe here. I think the ratio is out, right? Okay, but never mind. We just try to sketch it. So maybe 2 is here. Okay, so this is a line y equals to 2. Okay, so we start from the pi. When x equals to pi, the maximum point is a net 5. Okay, when x equals to 3 pi over 2, it will pass through the line y equals to 2. Then at 2 pi, your minimum point is -1. So you try to join them together in a curve. The basic shape is still the cos. Okay, so of course my ratio is a bit out. Therefore, my diagram will not be very nice. Okay, because you can see that this one unit is so big, that 5 unit is so small. So by right, you should follow the ratio. Okay, after you draw it out, it should be something like this. Then don't forget to label it again. This is the function gx, where you're having 3 cos x minus pi, then plus 2. Okay, so all the important features and maybe the coordinate, you just try to label it out clearly. Right. Okay, so this is how we solve the part B for question number 9. Then let's continue to part C. Part C, they want you to find the G inverse F with the value of pi over 3. So first of all, we actually need to find out the G inverse first. We know that our function gx is given like this, where it is 3, then cos x minus pi plus 2. This is my gx. To find out the inverse function, I will let y equals to the function gx first. I want to rephrase my equation, become x equals to something y to get the inverse function. Okay, then we try to complete it. Okay, move all the number to one side first. So by right, you'll be having y minus 2 over 3. Take the cos over, you will have cos inverse. So I'm having cos inverse, then y minus 2 over 3. Then after that, I bring the pi over. It will become pi plus cos inverse, then y minus 2 over 3. And we try to rewrite our function again. This will be our inverse function for the g, where you're having pi plus cos inverse. Change your equation in terms of x. Okay, so this is my inverse function of g. And this is not the end yet, because we need to substitute our value into the function and get the answer, right? Okay, and now let's continue from here. We are having the composite function of g inverse f by having the value of pi over 3. Usually for me, I will tell students, if let's say you're having a value, right, you just try to substitute the value slowly. Okay, then you composite the value into the function. Instead of you find the inverse the composite function first. To me, you find out the composite function will be slightly more complicated. Alright, so since they give us the value, so that means now first step is I want to substitute the pi over 3 into my function f. So what's my function f? My function f is cos x. So I will replace it by using cos pi over 3. Replace the x by using the pi over 3. What's the value for cos x? Cos pi over 3. So pi over 3 is 60 degrees. So cos 60 degrees, you'll be having the half. And now, you need to substitute the half into your function gx. So what do we have? So we're having we're having pi, then plus cos inverse, half minus 2 over 3. So half minus 2 over 3. What's the value that I get here? Okay, if you try to simplify it by right, you'll be having negative half. And when they're asking for cos inverse negative half, right, it should be in the fourth quadrant, but you measure it in, it should be in the fourth quadrant, sorry, no. You are having a negative value here, right? So for negative value, your cos negative should be in second quadrant or third quadrant. How can we get answer in second quadrant? Of course, you can directly press calculator to help you. But if you want to use MS calculator, right, then by right, you should be having the basic angle, which is 60 degree. Then in the second quadrant is 180 minus 60, so you have 120. So how to convert the 120 into the radian form? It should be 2 pi over 3. And from here, simplify it, you will get 5 pi over 3. But generally, I think this is not a big problem because if you press calculator, the calculator will directly give you the answer. Therefore, those who are using MS calculator, maybe you can just try to make it into degree first. Then after that, only you convert it into the radian by yourself. Alright, so this is what you have for 9C. Then let's continue to part D. They're asking you, explain why the composite function fg cannot be formed. Alright, if you want to explain, do a little bit of explanation here. Basically, you need to show them. Maybe we need to figure out, yeah, the arrow diagram between the composite function. Composite function fg, it actually means that you are starting from the function g first, then composite the function f, right? Okay, so in short, in overall, this is basically the arrow diagram for the composite function fg. And we know that the starting set of value is the domain, right? So this is the starting value for g, and it is basically the domain of the g. This circle is the n, okay, the image of the g, and we call it as the range of g. But at the same time, you realize that this is also the starting set for the f, function f. It is also the domain of the f. So this is the range of the f, okay? When you try to have a look for this center set here, basically they are having the equal, how to say, the equal set, they are sharing the equal set, okay? So from here, by right, to make sure that the composite function fg exists, you have to make sure that at least the domain, the range of g is equals to domain of f. Okay, or at least you need to know that the domain of f must be part of the range of the g. Okay, to me, I think they should be the same. All right. Okay, yeah. So basically, this is something that we didn't apply very often. So make sure that you are aware of this kind of arrow diagram, and you need to make sure that in the composite function of fg, your range of g must be equals to the domain of the f. Let's figure out what is the range of g first. In part B just now, we have tried to sketch the diagram, right? And from the diagram, you will know the range of the g. It is from -1 to 5. So let me write it out first. It will be from -1 to the +5. And how about the domain of the f? In the question, they already give you the domain of f, which is 0 to the pi. So do you see that is the range of g equals to the domain of f, or domain of f equals to the range of g or not? No, right? Yeah, so that's the reason why the composite function cannot be formed. Because if you want to form it, you have to make sure that they are the same. Therefore, you can just tell them that the domain does not include the whole g. The whole range of g. Okay, because when the range is bigger, right, then your domain is inside the range, right? Then how about, how can I send the range, the value that's outside the domain to complete the function, right? Actually cannot. So this is our reason. Okay, so to make sure that the composite function fg exists, you have to make sure the range of g is equals to the domain of the f. Right? Yeah, so this is how we solve the question number 9. Right, so question number 10. The equation of a circle is this one. They want us to find the equation of tangent to the circle at the point 28, giving your answer in the form of this. In short, in general, we are having a circle, and then I'm having a point 28. I want to find out the equation of the tangent, so that means this one. This is a tangent. Alright, to form any linear equation, right, to form any straight line equation, basically I need to have two information. The first one is the passing point, and I already have the passing point because it is a 28. The tangent line passed through the 28. The second information I need is the gradient. So what is the gradient for tangent for this particular point? For the circle, we don't know. So we have to figure out the gradient first. And to get the gradient of the tangent, I need to use a property of the circle, where I know that the center, maybe the center I label it as C. Okay, so the center C touch the point on the tangent, it should be a 90 degree. So from here, that means I need to have the center of the circle first before I can continue to figure out the gradient. Okay, so let us start. We want to find the center of the circle. To get the center of the circle, I want to change it become the standard form, and I want to complete the square for x and y. I'm having x squared plus 4x, right? Then I have to start the completing square process, plus something square minus something square. Same thing happens for the y, so I'm having y squared minus 8y. I also want to have plus something square minus something square. Then what else do I have? The number negative 12, I bring it over, become positive 12 first. Okay, so what should I fill in into the bracket here? Where's the something here? So something for this one is actually the coefficient of x divided by 2, b divided by 2 in short. So 4 divided by 2, you're having a 2 here. Then how about for the negative 8? You're having negative 8 divided by 2. So this is negative 4. And you're having also the negative 4 here. And to complete the square, you have to group the first three terms for the x into one big bracket, with x is the first term, 2 is the second term, with a square outside. Then the 2 square minus 4, you just put it as minus 4. Same thing happened here for the y also. The first three terms here, you try to put it into a big bracket. First term is a y, second term is negative 4, with a square outside. And then you're having negative 16. 4 squared is 16, right? That equals to 12. Okay, we keep the bracket with a square on the left. Then all the value to the other side. And this is 32. And from here, you successfully get the center of the circle. I label it as C, right? Which is negative 2 and also 4. Okay, then this is one of the important value or important information that I will need to continue my calculation for equation of tangent. Okay, then next, after you get the midpoint, you know that the midpoint, the gradient from C to this line is equals to the is perpendicular to the tangent. Therefore, I know that what should I use? Maybe I use the purple color. Now we try to figure out the gradient, yeah. So I say the gradient of the center. Okay, I didn't write it out, so it should be gradient of the center to the point multiplied with the gradient of the tangent. It should be equals to negative 1 because of they are perpendicular to each other. So let me find the gradient first. So how to find the gradient? I want to find the gradient from C to 28. Okay, and now y minus y1, so 4 minus 8 divided by x minus x1, so negative 2 minus 2. The gradient from the center to the point 28 is by right it should be negative 1, right? Positive 1. negative 4 divided by negative 4. So you're having a 1 here. Okay, so m is a 1 multiplied with the gradient of the tangent where it is equals to negative 1. Therefore, the gradient of tangent is negative 1. Okay, so again, let's have a look for our diagram again. To find the equation of tangent, I need passing point. I got. Then now I also have the gradient of the tangent. So from here, I can start forming the equation of tangent using this information here, right? Okay, then equation of tangent is y minus y1, where the passing point is the 8, right? For the y coordinate equals to m. M is negative 1. Then x minus x1. So what's the value for the x? It is actually the 2. Okay, and then after that, read the question one more time. They want us to rewrite our answer in terms of the general formula, right? So it should be having x plus y minus 10 equals to 0. So please follow the final answer that the question requested, right? They want us to put our answer in this form. Okay, so this is what we have for the equation of tangent. Then let's continue to part number B. Now we are having the line do not intersect the circle. Then they want us to show that we got this equation here. Okay, we are still talking about intersect. So try to imagine if you want to find the intersection point between the line and also the circle. What should you do? You have to substitute the line into the curve equation, right? Okay, so I rewrite again, yeah? My circle equation is this one. This is my first equation. And my line equation is x equals to k minus 3y. I will put it like this. Okay, when I want to solve for intersection point, I will substitute 2 into 1. That means I want to solve the equation simultaneously. What is the x here? I'm having k minus 3y plus 2 square, then plus y minus 4 square equals to 32. Okay, we try to expand it. If you try to expand this whole equation here, by right you'll be having k square. Expand it carefully, 3ky, 2k minus 3ky plus 9y square minus 6y plus 2k minus 6y plus 4. Very long, because if I expand all the brackets slowly, it might be maybe easier if you try to expand it into the original equation circle of the circle instead of the standard form. Okay, yeah, so I think I am choosing a longer way because if you want to expand this one, it is quite long here. Okay, so I have do a little bit of expansion, so you try and check whether my answer here is correct or not. After you expand it, try to simplify all the terms that you can, and I want to group them in the form of the y, because you can see that we're having y square and also the y. If I group it in terms of y, so I'm having 10y square, then simplify everything here, should be having negative 6k minus 20 with the y, and also I'm having k square plus 4k minus 12 equals to 0. Okay, so after you simplify everything here, by right, this is the equation that you should get. Right. And since they are telling us that the line and the curve does not intersect, so that means if let's say I'm having a circle, right? This particular line does not intersect with the circle. So that means there's no intersection point or no real root. Therefore, we are going to use the concept of discriminant, where b squared minus 4ac should be smaller than 0. What is your b? Your b is this one. What is your a? A is a 10. And what is a c? C is this whole thing here. Okay, so let us substitute into our equation here, inequality here. Negative 6k minus 20 square minus 4. Then a, then c. And it should be smaller than 0. Okay, then continue further, you just need to do a little bit of expansion. Alright, so I should be having 36k squared. You try to expand it by yourself and see whether do you get this one or not. Okay, then simplify everything. By right, you'll be having k squared minus 20k minus 220. And it is greater than 0. So please make sure that you get the equation of inequality that the question wants you to show. Alright, so if you can't get, that means there's something wrong with your expansion, or maybe you did some careless mistake somewhere. Alright, so if you don't have any careless mistake here, by right, this is the answer that you should have. Okay, yeah, so this is the end of this paper 1.5. So thank you very much for watching the video.